Okay. All right, so here is a beginning average acceleration problem for you to practice if you need additional support. So here in this particular problem, I have a problem that says a car accelerates uniformly from rest at a rate of 6 meters per second square, as shown in the figure below. Okay, so keep in mind 6 meters per second square. Meters per second square implies that this value represents your acceleration. And then it says uniformly. Uniformly just means constant, that the acceleration for the whole entire problem does not change. Okay, so for the example here. So you need to read A, B, C, and D, and then I'll show you how to do these types of parts, and then hopefully adapt a strategy that helps you understand the stuff. Okay, so here in the diagram, it says here the initial velocity is 0 meters per second. So at times equal to 0, the car is just stationary, so it's kind of at the starting line waiting to go, and then it accelerates to the right. In this case, the diagram has the acceleration to the right as 6 meters per second squared. Okay. So let's do part A. To do part A, I do want to point out that it says instantaneous velocity, or V of t. Anytime it asks you to find instantaneous velocity, it's asking you to find the final velocity at that particular time. So part A, well, at what time? It says 1 second. So we're just going to go from 0 second to 1 second. Okay. So to find the velocity at 1 second, we need to introduce VF. So here, by definition, acceleration is just a change in velocity with a change in time. But you notice here this function doesn't have a VF, it just has change in velocity. But you need to recognize you can break up delta V into VF minus VI. Once again, we need to break it up because we're trying to find VF, right? We're not finding VI, and we're not trying to find change in time. We're just trying to find VF. So to get VF by itself, algebraically multiply both sides by delta T first. So make sure you do your algebra in the proper step here. If not, you'll goof. Okay, so the first thing to do is get rid of that delta T on the bottom by multiplying. And then once you do that, you have delta T times A is equal to VF minus VI. Or you can write A times delta T, right? When you're multiplying, it doesn't matter which order you write the variable in. I just like A times delta T. It's just something I'm used to writing. But if you want, you can simply keep it as delta T times A. It doesn't change the outcome. But once again, on the right side though, you notice VF is not by itself yet. You have a minus VI. So to get rid of this minus VI, you need to add it to the other side, or add VI to both sides, however you want to say it, okay? So the final expression though, if you do your algebra correctly, is just A times delta T plus VI. Now that we have this expression for VF, which is your instantaneous velocity at whatever specific time the problem wants, you can just plug and chug. Well, A is 6 meters per second squared. T here is just 1 second because it says after 1 second. Well, what is my initial velocity? Well, the problem states that at 0 second, the car is at rest. So VI for this one at times equal to 0 is just 0. And then this is meters per second square. The time here is just 1 second. So second square suggests that there are two S's, S times S. So the units will cancel out here. So that square in the unit is going to cancel with the S because there are two S's. So it leaves you just with the units of meters per second, which is the proper unit for velocity. Okay. But you notice here on the top right of the screen, I put here in my final answer is positive 6 meters per second. That's because the question here asks you to find the instantaneous velocity. Velocity is a vector quantity in physics, so you need to have a magnitude and a direction. The magnitude here being 6 meters per second, the direction being positive because the diagram shows the car accelerating to the right. Okay, so let's do part B. Part B wants us to find the instantaneous speed, or aka the absolute value of your velocity. So essentially, magnitude here, or the absolute value here, just means just provide the number and the unit. Do not include the direction, okay? After 3 seconds. Well, to do this is pretty light work, right? We already have an expression for VF, so I'll just use it. So VF here, once again, is A times change in time plus VI. Well, I know A is given as 6. My change in time here is 3 seconds because it says after 3 seconds. So I will go back to 0 second. From 0 second to 3 second is a difference of 3 seconds, okay? Well, if I go back to 0 second, my VI is 0. So therefore, for this one, it's really just 6 times 3, which is 18 meters per second. All right, that's it. So the answer here is just 18 meters per second without any directions because it says speed, and speed is a scalar quantity. So pay attention to quantities in physics, whether it's a scalar or vector, and make sure you present your answer properly. Now, before I do part C, I like to go ahead and teach you how to do this particular chart. So hopefully, hopefully you keep up here. If you can do this chart, a lot of these average acceleration problem and VF and change of V is super fast to do. Okay. So here, if you want, learn how to set up a T, A, and V, or you can do T, V, and A. It doesn't really matter the order. I just like to keep T on the left side just because, a lot of these problems reference this time, okay? So here, the easiest column to do for this particular problem is A. A is just 6, all the way down, right? Why? Because it sets uniformly at a rate of 6 meters per second squared. So uniformly suggests that the value doesn't change. So it would be 6, all the way down, okay? Well, the next thing I want to do is just fill out the time. I'm going to start at 0 second, go to 1, go to 2, go to 3, go to 4, 5, and so on, however many you want to do based on the problem. Now, on the right side, okay, this velocity quantity here is super easy to do, okay? Well, all you have to do is be consistent. At times go to 0. The problem sets that the car accelerates, after that. But at times you go to 0, the car hasn't moved yet, right? So therefore, the velocity is 0, okay? So don't put 6 here. At times you go to 0, the car hasn't moved, so its velocity is 0. For this problem anyway. And then 1 second later, how fast is it moving? 6. Well, how do I know that? Well, the acceleration tells you that for every second, your velocity changes by 6. So acceleration is known as the rate of change in velocity, right? How fast is your velocity changing for every second that goes by? Okay. So here, my initial velocity is 0 at times equal to 0. At 1 second, it's moving at a rate of 6. And then, well, how fast is it moving at 2 seconds? Well, easy. 12. Well, how do you know it's 12? Because you just keep adding 6. And what's the next number? Well, 12 plus 6 would be 18. 18 plus 6, would be 24. Okay? So that's how you can find your velocity at these nice time intervals super fast. Now, watch my screen here on the right. Well, from 0 to 6 is the difference of 6. Right? From 6 to 12 is the difference of 6. From 12 to 18 is the difference of 6. And then 18 to 24 is also a difference of 6. Right? So you notice here, all these 6 that are in red, well, what does that represent? Well, it represents your acceleration. How do I know that? Because all of these arrows is 1 second. This is from 0 second to 1 second, which is a difference of 6. And then from 1 second to 2 seconds is also a difference of 6. And then from 2 seconds to 3 seconds is a difference of 6. So essentially, it's very consistent. It tells you your velocity changes by 6 for every 1 second. Okay? Now, well, what if it's not like a whole number? What if it's not 1 second? What if it's like a half a second? Well, here I have it where I have 4.5 second, right? Instead of going to 5, I just went to 4.5. Well, what's your A? Your A is still 6, right? Don't fall for that trap where you're going to change stuff. A is 6 all the way to however many seconds you want. Well, what's this answer? Well, this answer is 27 because if you change by 6 every second, well, how much do you change by for just a half a second? Well, it would just be half of 6, which is just 3. So you would just take 24 plus 3, and your answer would be 27. Okay, so I hope you're keeping up with the reasoning there. And if you don't like that, then just go back to your physics function, and I promise it will give you the same outcome. All right. I just like this chart because it doesn't take that long to fill out this chart, and then once you have it, hopefully you can learn how to use it and then not goof. Okay. Now let's do part C. All right. Part C asks us to find the change in velocity for the first 2 seconds, from 0 to 2 seconds. So I'll just I'll just apply the physics function. A is equal to change in velocity over change in time. It asks for the change in velocity, so I'll keep change in velocity just as is. I won't break it up. But to get change in velocity by itself, multiply both sides by delta t. So we can say that A times the change in time is your change in velocity. Well, what's your A? 6. What's your change in time for this particular part? 2 seconds, because it's just the first 2 seconds. All right, so here's delta V as our unknown, our variable. Well, 6 times 2 is just 12, right? So we know that the velocity changed by 12 meters per second during the first 2 seconds. Well, if you are able to keep up with this chart and hopefully practice as you get these different types of problem, here's my arrow that just came up. Well, my arrow here starts at 0 second. Why? Because this is 0 second. I'm going to go all the way to 2 second, right? So if you go follow my cursor, this is 2 second. Well, what is the change during this time interval of 2 seconds? Well, your value starts at 0 because the car is at rest, and then the velocity here after 2 seconds is 12. Well, 12 minus 0 is just 12. So that's also an easy way to just come to these conclusions quickly without, having to punch in or having to write out physics equation and punch in a bunch of stuff on your calculator. Okay? All right, I hope that helps. Now, So therefore, the answer for part C, though, don't get sloppy yet. It asks for the change in velocity. Velocity is a vector, so make sure you include the direction. So it would just be positive 12 meters per second. So the change is positive 12 meters per second. All right, let's do part D. Part D wants us to find a quick ratio between the change in velocity for the first 3 seconds and the change in velocity from 2 to 4 seconds. Well, in order to do so, in order to figure out what this blank is, in order to make it a true statement, we can just find delta V here and then delta V there and just make a comparison, okay? Well, in order to find delta T from 0 to 3, once again, I'll just go ahead and apply the physics function here. Acceleration is 6. My change in time here is 3 because 3 seconds minus 0 is just 3. So therefore, my change in velocity here is just positive 18 meters per second. I'm doing a ratio problem here, so I don't really care about direction, okay? Because ultimately, you're asked to find a coefficient, not the actual velocity quantity. So I would just say the change is just 18. If you want, you can put positive 18. It doesn't hurt, okay? So I already found the change in velocity for 0 to 3. Now I need to find the change in velocity from 2 to 4. So I can just do the same physics, except just change my time interval. Well, acceleration is still 6. Well, what's my delta T now? It's 2 seconds because, well, from 2 to 4 is the difference of 2 seconds, right? Or you can do 4 minus 2 is 2. Now, 6 times 2 is just 12. So my change in velocity from 2 seconds to 4 seconds is just 12. So now that you have 18 and 12, you can just plug it back into the statement. So this is really easy. Well, the left side, so instead of saying change in velocity from 0 to 3, you can just say the change is 18. Equal, carry down the blank. Well, what is your change in velocity from 2 to 4? Well, we already found it. It's 12, right? So solve for the blank. You can put excess the blank. I'm just going to use the symbol star here. Well, how do you get star by itself algebraically? Let's just say 18 is equal to star times 12. Well, what's the opposite of multiply? That's just the divide. So to find star, divide both sides by 12. So it just be 18 over 12. And if you simplify that on your calculator, your star coefficient should come out to be 1.5. Okay, so the coefficient here is just 1.5, which makes it a true statement. All right. Other than that, if you understood the chart, here's how you can come up with 18 and 12 super fast, right? The statement initially says from 0 to 3 and then 2 to 4. Well, here you go. From 0 to 3, 0 second, 3 second, 0 meters per second, all the way to 3 second, which is 18. So what's the difference there? 18. Okay, so I'm trying to make a point here. If you can fill this chart out quickly, these different types of ratio, VF, change in V, is super fast. Well, what do I do with the second statement? It says from 2 to 4. So just draw an arrow from 2 to 4 seconds. Well, it went from 12 to 24. Basic math. 24 minus 12 is just 12. So right away, you see how you can come up with these two conclusions, 18 and 12 super fast, without doing all this math here, okay? Pick a strategy that helps for you. I hope that helps. Stay nerdy. Don't be whack.